applies. In this video, let me discuss about the convergence of Fourier series. Before that, let me have a short look over what is Fourier series. You know already, Fourier series are particularly suitable for expansion of periodic functions. That is, Fourier series is an infinite series representation of periodic function in terms of trigonometric sine and cosine functions. And in short, we have to say Fourier series is to be expressed in terms of periodic function, that is in terms of sine and cosine functions. So let me have a short look over the mathematical definition of Fourier series. Let f of x be a periodic function and satisfy Dirichlet conditions in the interval 0, 2 pi. Then f of x can be expressed as an infinite series of the form f of x is equal to a naught divided by 2 plus sigma n varies from 1 to infinity a n cos n x plus b n sin n x. Is called a Fourier series where a naught, a n and b n are called as Fourier coefficients of f of x in 0, 2 pi. With this short introduction, let me now move on to the convergence of Fourier series. So before that, let me give you some hint about what is the meaning of continuous point and discontinuous point. For that, suppose if f of x be a function defined, whatever may be the function, okay. So if it is defined in an interval 0, 2 pi, so f of x be any function that is defined in the interval 0, 2 pi. Here 0, here I am going to take the interval is an open interval, which means x takes all values, that is I am going to write this as 0 less than x less than 2 pi. That is x takes all values between 0 and 2 pi except 0 and 2 pi. Isn't it? So I am just draw a number line which gives you a clear idea about what is the meaning of it. Here the length of the interval is from 0, 2 pi, that is 0 to 2 pi. So inside the interval we are having so many points. Randomly I am going to write some of the points: pi by 4, pi by 2 and pi and 3 pi by 2, etc. Like this we are having so many points inside the interval 0, 2 pi. So at x equal to pi by 4, which means that is a continuous point, which means that point is inside the interval. If the point is inside the interval, that is a continuous point. At x equal to pi by 2, that is also continuous because that point belongs to the interval, that is inside the interval. At x equal to pi, that is also continuous. X equal to 3 pi by 2, that is also a continuous point. But at x equal to 0 and at x equal to 2 pi, whether the point is continuous or discontinuous. At x equal to 0 means x takes all values except at 0 and 2 pi. So x equal to 0 means at x equal to 0, that is a discontinuous point. There is a discontinuity arises at the point x equal to 0. At x equal to 2 pi also that point doesn't belong to the interval. So there is a discontinuity arises at that point. So x equal to 0 and 2 pi, both are discontinuous points. So here what is our conclusion? Here x is continuous. X is continuous at all points except at 0 and 2 pi. Here both 0 and 2 pi are discontinuous point except these 2 points, all the other points inside the interval are, we named it as a continuous point. So instead of that, you may ask the question, suppose we have to take the function f of x, whatever may be the function, defined in the closed interval 0, 2 pi. Here I am going to use a square bracket, which means that's a closed interval. Here x takes all values including 0 and 2 pi. So if I am going to use the parenthesis like this, which means x takes all values except 0 and 2 pi. It takes all values between 0 and 2 pi. If I am going to use a square bracket like this, which means that is a closed interval, this is an open interval. This is an open interval. This is a closed interval. So which means x takes all values including 0 and 2 pi. So if I am going to draw a number line, the same that we have do as before. So the length of the interval here is 0, 2 pi. So some of the points I am going to list out here: pi by 4, pi, 3 pi by 2, etc. Here all points are continuous. Pi by 4 continuous point, pi is a continuous point, 3 pi by 2 is a continuous point. Look at the end points. Here 0 is a continuous point because that is inside the interval, because x takes the value, because the meaning of less than or equal to, which means x takes the value 0, including 0 it takes all points. And at x equal to 2 pi, that is also continuous because x takes less than or equal to, which means x takes the value 2 pi 2. So here, so what is the conclusion here? X is continuous at all points, including 0 and 2 pi. So there is no discontinuous points here. Okay, so x is continuous at all points including 0 and 2 pi. Like that, one more interval here we have discussed in this section, that is minus pi comma pi. If it is an open interval like this, which means there are two discontinuous points, isn't it? Minus pi to, let me take the another interval. If it is minus pi to pi, what is our conclusion? Only minus pi and plus pi, those 2 points are only discontinuous points. All the other points inside the interval, the center we have 0, like that. Here we have minus pi by 2, plus pi by 2. All the other points here are continuous points. If it is a closed interval, that is minus pi to pi, if it is a closed interval, what it means? All points are continuous including minus pi and plus pi. So there is no discontinuity. If it is in case of closed interval, there is no discontinuity at the end point. So here you just note only one point. If the function is defined in the whole range, that is in one interval, the discontinuity arises only at the end point of the interval. The discontinuity arises only at the end point. If the interval is an open interval, definitely the discontinuity arises only at the end points. If it is a closed interval, definitely there is no discontinuities. Okay. So one more function we have built, most probably that is in case of splitted interval. Suppose a function is defined in a splitted interval like this. Definitely there may be a discontinuity arise both either at the end point or at the middle of the interval. So this case arises only in case of splitted interval. For example, any function f of x defined in the interval minus pi comma 0 and 0 comma pi. Here I am going to take the interval minus pi to 0 and 0 to pi. What is the meaning of it here? That is, here x takes the value 0. The length of the interval here is 0 and minus pi to pi. The length of the interval is minus pi to pi. But instead of taking a single value, that is a one value in the whole range, it takes two different values. That is, in minus pi to 0, it takes a value, x takes a value minus pi to 0 at some function value, and 0 to pi means 0 less than x less than pi. So x takes two different, that is a function takes two different values in two different intervals. That is minus pi less than x less than 0, which means what are the discontinuous points here? Minus pi to 0 and 0 to pi. Okay. So this minus pi is a discontinuous point, isn't it? That's an open interval, that doesn't belong to the interval, and 0 is a discontinuous point. Pi is also a discontinuous point, because all these 3 points are discontinuous. Here minus pi and plus pi occur at the end of the interval, end points of the interval, and 0 is at the middle point of the interval. So here, except these 3 points, all the points are continuous. Suppose if I am going to take minus pi by 2, that is a continuous point. If I am going to take plus pi by 2, that is a continuous point, because that is inside the interval. So only these 3 points. So here x is continuous at all points except at x equal to minus pi, pi and 0. Look at here, minus pi and pi both are discontinuous points at the end of the interval. Here 0, that is discontinuity. Here suppose if I am going to find the value of the function at x equal to 0 means Here the discontinuity arises at the middle point of the interval. Okay, these two is nothing but end point of the interval. So if the discontinuity arises means that may be either arise at the end point or at the middle point of the interval. So now you hope you got a clear idea about what is the meaning of continuity and discontinuous points, right? So now let me see how the Fourier series of f of x converges to f of x, that is at continuous and discontinuous points in detail. This table gives you a clear idea about all this in one. Now the function is continuous. What we are going to do is we just substitute the value directly. For example, I am going to take the function f of x is equal to x in the interval 0, 2 pi. What is the meaning of it here is f of x is a function defined in the open interval 0, 2 pi. If it is an open interval, what it means? That is 0 and 2 pi. That is, it takes all values except at 0 and 2 pi. Now, I am going to find the value of the function at x equal to pi by 2. Okay, now I am going to find the value of the function f of x at x equal to pi by 2. And just look at the point x equal to pi by 2 whether lies inside the interval or not. So x equal to pi by 2 is approximately here, isn't it? So that is inside the interval. So that means that is a continuous point. If it is a continuous point, what we are going to do? You just substitute the value directly. So what is your given function f of x equal to x? Just replace the value of x by pi by 2. If you replace the value of x by pi by 2, what happens? The function is also defined as x itself, so pi by 2. Suppose instead of that, if the function is defined as f of x equal to x square in the same interval 0, 2 pi, I am going to find the value of the function f of x at pi by 2. What it means? Pi by 2 is a continuous function. So just replace that is pi by 2 the whole square as the answer, isn't it? So now if it is a continuous point, what we are going to do here is you just substitute the value directly. Okay, you just keep that in mind. If it is continuous, no worry, you just substitute the value directly. Suppose if there is a discontinuous, that is a given point, that is the value of the function, we are going to find the function value. What we are going to do here is there may be two cases arise here. As I told you earlier, discontinuity arises either at the end point or at the middle point of the interval. So discontinuity arises if it is at the end point, then what we are going to do? If it is at the middle point, then what we are going to do? That is what we are going to discuss now. So if the discontinuity arises at the end point, then what we are going to do here is you have to take the average of the values at end points. Here itself I am going to take the same function that we have discussed in 0, 2 pi here. The f of x equal to x in the interval 0, 2 pi, that is an open interval. If it is an open interval, as I told you earlier, so it is 0 and 2 pi. Here x is, this is an open interval, which means only there are two discontinuous points 0 and 2 pi, and all other points inside are pi, pi by 2, etc. All are continuous points. Okay. Now, what we are going to do here is just leave this. Look at the values at 0 and 2 pi. So now we have to find the value of the function f of x at x equal to 0. Now I am going to find what is the value of the function at x equal to 0. What we are going to do first, we have to check whether this point is a continuous point or discontinuous point. At x equal to 0, for that just look at the interval. X equal to 0 means this is an open interval, isn't it? Open interval means x takes all values, that is 0 less than x less than 2 pi. So x takes all values except at 0 and 2 pi. So there is a discontinuity. So at x equal to 0 is a discontinuous point which arises at the end point of the interval. Discontinuity at the end point. So if the discontinuity arises means definitely we will check whether if it is at the end point or at the middle point. Here 0 is at the end point of the interval. If it is at the end point of the interval, then what we are going to do? We have to take the average of the values at end points. So the value of the function f of x at x equal to 0 is average of the values at the end point, that is f of 0 plus f of 2 pi divided by 2. So the value of the function at x equal to 0 is nothing but here f of x is x. So you just replace the value of x by 0, what you get? 0 itself. f of 2 pi. Just replace the value of x by 2 pi. What you get? 2 pi. Because here the function is defined as x alone. Okay. So 0 plus 2 pi divided by 2, that is nothing but pi itself. Now you may ask one more question for me too, isn't it? Instead of finding the value of the function x equal to 0, at x equal to 0, suppose if I am going to find the value of the function at x equal to 2 pi, at x equal to 2 pi, what is the function value at x equal to 2 pi? The same answer, isn't it? Instead of finding the value of x equal to 2 pi, I am going to find the value of the function at x equal to 0. Instead of finding the value of the function at x equal to 0, if I am going to find the value of the function at x equal to 2 pi, the same formula. Here 2 pi is also a discontinuity. Discontinuity arises at the end point. The end point may be at the starting point or end point of the interval. No matter. Right? So you just take the average of the values at the end point, the same formula, and you get the same answer. So the value of the function f of x at x equal to 0 and x equal to 2 pi, both are having the same answer, pi. Now let me move on to the next case. What will happen if the discontinuity arises at the middle point of the interval? This occurs only when the function is defined in a splitter interval like this. Okay, instead of function defined in a whole range, it takes two different function value. So if it is like this, then how can you find the value of the function at this discontinuous point? For that we make use of, that is, left hand limit plus right hand limit divided by 2. You just add both left and right hand limit divided by 2. I am going to take the function f of x that is equal to x in the interval 0 and 2 pi, and the function f of x is equal to x square in the interval pi to 2 pi. That is, f of x takes the value x in the interval 0, pi. I am just draw this here. So the full range is 0, 2 pi. Instead of defining the function f of x as a single function, take two different function values. So at 0 to pi, it takes a value f of x equal to x, and pi to 2 pi, it takes a value x square. So it is an open interval, isn't it? 0 less than x, pi to 2 pi. This is also open interval. So here 0, pi and 2 pi all are discontinuous points. Now I am going to find the value of the function at x equal to pi. Here pi is a discontinuous point, but here the discontinuity arises at the middle point of the interval, isn't it? Pi is the center point. Here the discontinuity arises at the center point, that is the middle point of the interval. If so, what we are going to do is just find the left hand limit of the function and right hand limit and divide by 2. What is the left side value of the function value at x equal to pi? F of x equal to x. Okay. So f of x equal to x, that is nothing but pi itself. Just replace x by pi, you get pi. And right hand side value of f of x at x equal to pi is f of x is x square. Just replace x by pi, what you get? X square is nothing but pi square. That is pi plus pi square divided by 2 is the function value. Instead of writing left hand limit plus right hand limit, you make use of f of pi minus f of pi plus. Pi minus means the function value of x equal to pi at the left hand side. F of pi plus means the function value of f of x at x equal to pi in the right hand side, right? So both you can add both the left and right hand side limit values and divide by 2, that gives you the function value at the middle point of the interval. So up to this, hope you got a clear idea about the convergence theorem of Fourier series. Thanks for watching. See you all again in my next video.